Good. All right. So, if this is your first time, welcome. Everyone say, "Oh, those are the cutest kids I've ever seen." All right. So, okay. So again, in here, I think this Nelson's been doing something pretty similar, but I'm going to give you a minute. I'm going to literally set a timer. I'm going to give you a minute to try to solve each question. Then after that minute, we'll go over it together, talk about strategies for solving that question, et cetera, et cetera, et cetera. So, we're going to do that right now. I'm going to give you a minute to solve the first one. And answer question number 1. If a marble is randomly chosen from a bag that contains exactly 8 red marbles, 6 blue marbles, and 6 white marbles, what is the probability that the marble will not be white? It's the statistics and probability page. I don't think there's actually any page. So, 20 more seconds. That one, you might already. Okay, in 3, 2, 1. Raise your hand for F, for P, for H, for J, for K. Good. Yeah, it's K. It's K. And remember, if you don't know the answer, you guess, right? Because that's what you do on the ACT. If you don't know the answer, you don't leave a blank, you guess. Welcome, welcome, welcome. So, the marble is randomly chosen from a bag that contains 8 red marbles, 6 blue marbles, and 6 white marbles. That is 20 total marbles. Right? And what is the probability that the marble will not be white? Well, there are only 14 marbles that aren't white, the red and the blue ones. Well, Mr. Burrell, 14 out of 20 isn't an option. What am I supposed to do? Gotta simplify that fraction. 14 over 20 simplifies to 7 over 10. So that's where the 7 out of 10 comes from. Okay, you all got that. I don't think we need to dwell on that too much. Okay, let's see. Number 2. I'll give you a minute. Number 2, ready, set, go. Ready, set, go. Thanks. I have an answer, even if it's a guess. Two, 1. Raise your hand for A, for B, for C, for D, and for E. The answer is indeed D. Okay, so let's take a look here. A certain type of notebook costs $2.50 before sales tax is added. Notice this problem, I'm never adding sales tax, so I'm just dealing with before sales tax. This is a non-taxable notebook. So I buy 9 of these notebooks and I receive 1 additional notebook free. So $2.50 times 9 notebooks, what was that? Okay, 2 to 15, $22.50. That's how much it is for 9 notebooks. And I get an additional notebook for free. So technically I have 10 notebooks, but I only paid $22.50. So the average cost per notebook for the 10 notebooks is $22.50 divided by 10, which is how I get the $2.25. If you accidentally added another $2.50 for the 10th notebook and then divided by 10, you would have ended up with $2.50. Since the last notebook is free, I don't add the two. Cool. That feel good? Love it. Love me some probability. Let's take a look at question number 3. Ready, set, go. I'll give you a minute. Number 3. Kaya, bless her soul, drove 200 miles in 5 hours of actual driving time. Driving an average of 10 miles per hour faster than Kaya could have saved how many hours actually? Got 5, 4, 3, 2, 1. Here's your figure out for A, for B, for C, for D, and for E. Okay? Okay, the answer is indeed D. Yes, it is D, not B. So I'll show you how I went about solving this. Curious if anybody solved it any differently. If Kaya drives 200 miles in 5 hours, the speed that she's driving, 200 divided by 5, would be 40 miles per hour. She's driving 40 miles per hour. So by driving 10 miles per hour faster, that means she's actually going 50 miles per hour. Okay? And if she goes 200 miles going 50 miles an hour, okay, 200 divided by 50, it would take her 4 hours to drive the 200 miles. Which is why sometimes you might have been tempted to put 4 there, because it took her 4 hours to drive the 200 miles. But what was the question actually asking here? I could have saved how many hours of actual driving time. See how sneaky the ACT is in wording that question? Originally it took her 5 hours. When she went faster, it only took her 4 hours, so she saved 1 hour of driving time. The ACT loves to do that. Makes you think you're solving one problem, but really hidden in the wording, that's actually solving a different problem. They saved an hour of driving time. Okay? Any thoughts, comments, concerns, suggestions, recommendations? Cool. Let's move on to number 4. Okay, I'll give you a minute. The chart shows the current enrollment in all the mathematics classes offered by Eastside High School. Average number of students enrolled per section in Alpine. Okay, that was way longer than a minute. I'm so sorry. Raise your hand for F, for G, for H, for J, for K. It is indeed, what did you say? H. It is indeed H. And this problem is one, again, the ACT, it gives you this whole bunch of information, pre-algebra, algebra 1, geometry, algebra 2, pre-calculus. Really, it only wants the average number of students enrolled in each section of, algebra 1. Not this one, just algebra 1. Okay? So you just had to take the average of 24, 25, and 29. So you add those all together, right? 24 plus 25 plus 29, all divided by 3, because there was only 3 sections of algebra 1, and that gave you 26. All right? Okay. Okay. Let's see here. Question 5. Question 5. I'll give you a minute. Company earned a profit of $8 million each year for 3 consecutive years. For each of the next 2 years, the company earned a profit of $9 million. For the 5-year period, what was the company's average yearly profit? Okay, and 5, 4, 3, 2, 1. There's your number F, for G, for H, for J, for K. Yeah, it's H. What are you guys thinking in your brain? Like, if only all the ACT questions were like these ones. Right? So a company earns a profit of $8 million for each of 3 consecutive years. $8 million for 3 years, and then $9 million for the next 2 years. Over a 5-year period, the average, I'm sensing we're all comfortable with finding averages. 8 plus 8 plus 8 plus 9 plus 9 is 32. 42 divided by 5 is indeed 8.4 million. I'm not going to spend too much time on that one because I think we're feeling okay. Gosh, sorry. You even said 42 and I wrote. Why did I have 32 in my brain? I'm sorry. 42. The answer to all of the universe and everything. Okay? Yeah. All right. Question 6. Go ahead and try question 6. I'll give you a minute. The graph below shows the number of cars assembled last year in 4 cities. So there's 5,000 cars according to the graph. The fraction of cars assembled in all 4 cities assembled in Coopville. That was fun. The problem. Oh, it's Did you watch that already? Yeah, I like that. They said the ball. Okay, 5, 4, 3, 2, 1. Raise your hand for A, for B, for C, for D, and for E. Yeah, this one is B. Okay. Couple ways you could have gone about this. Each card stands for 10,000, right? So you could either do like 10,000 plus 10,000 plus 10,000, like add up how many total in 10,000s there were, right? And then compute the fraction that way. Raise your hand if you did that. I'm just curious. Okay, awesome. So you ended up with like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10,000s. So it was like 100,000 on the bottom. And then just the cars in Coopville would be 1025,000, and then you divided those. Is that what you're doing for those who did that one? Okay. Maybe I do it a different way? Go ahead. You just counted the total cars, so instead of like in terms of 10,000s, there was 10 total cars. Right, exactly. So I can just keep it at 10. And then there's 2.5 cars in Coopville, 2.5 out of 10. It is the same as 25,000 over 10, 100,000, so you could get the same fraction. 1/4 of the cars are from Coopville. Right? Cool. Is that fine? All right. All right. Last but certainly not least, question 7. Go ahead and take a minute. Question 7. Douglas, bless his heart, wants to draw a circle graph showing the favorite colors of his friends. He told his friends asking each of their favorite color. 25% of his friends said red, 30% of his friends said blue, 20% of his friends said blue, 10% of his friends said purple. The remaining friends said colors that other than red, blue, green, purple. Colors other than red, blue, green, that are in other sector. What will the green measure be? Other sector. Okay. Seconds reading that question area, please. 5, 4, 3, 2, 1. Raise your hand for A. Raise your hand for B. Raise your hand for C. Raise your hand for D. Raise your hand for E. A lot of options for D that time. The answer is indeed B. For Burrell. Okay, so let me point out some common mistakes made on this one. First of all, adding up all of these percentages, 25% for red, 30% for blue, 20% for green, 10% for purple, that adds up to a total of 85%, which would leave 15% of the circle to be the other sector. So if this was your circle, you had like 25%, 30%, 20%, 10, whatever. Say this sector right here is a 15% sector, but that's a percentage, right? It wanted what will the degree measure of the other sector be? So how many degrees are in a full circle? 360 degrees. So 360 degrees times 15% times 15% or times 0.15. 15% of 360 degrees is, I didn't actually type that on my calculator, but 54 degrees. Does that make sense? Again, a little bit sneaky. It's just in that last line that he says, what will the measure be of the other sector? Where we're tempted because we're working with percentages to do a percentage, but it wants the degree measure, so it would be 54. Cool. So good? All right. And that's it. That's all the statistics and probability questions. So I'm going to go ahead and pause the video for our viewers watching at home.